Huge piles of scrap at a scrapyard. A private business that sells metal to foundry operations. Huge amounts of energy, human labor and time were invested into making all the objects you see here before you, or needed to be mined from the earth by heavy mining equipment that ran on fossil fuels, smelters, steel mills, furnaces, forges that also needed to be built and operated, requiring even more of those resources. By melting these objects down, you essentially remove much of the energy and labor that was invested into forming a raw material into a useful object. Energy, labor, and human lifetime that can never be brought back. In short, by scrapping instead of reusing and repurposing, you drive entropy forward. However, many of the repairs I have shown in my videos over the years would not be financially viable but for one fact. It's not economical to invest so much thought and time into repairing many of these objects, unless 100,000 people watch me do it. Now all of a sudden it is. And I really try to share knowledge here. But think about this for a second. I can teach 100,000 people how to tell different kinds of electric motors apart, how to get them running, how to use all the different machines in a metal shop or explain how circuits work. And yet in most months this probably makes less money than a teacher teaching a class of 30 or 40 kids, and certainly less than a private tutor teaching one wealthy individual. There you have it. And the reason for that is of course that platforms like YouTube are blind to the actual content. With all their BS, AI features and all the computing power in the world, a video about electromagnetism, for example, has the same value as a video about a hot dog eating contest. See, when I was a kid, I believed that with all the knowledge and technology that we acquired, we were headed for a more enlightened future. But are we really? Be that as it may though, I don't feel like giving up. So let's see if we can find a few things here today that might be interesting enough to have a closer look at. I have, for example, never seen anything like this odd-looking contraption here, but I can tell it's something quite unusual. So let's take that home. Over here, a local hospital or another type of health institution of some kind has dumped several devices that would have been incredibly expensive when they were new. What are these things? Well, I'll tell you all about it once we are back at the workshop because I bought this entire pile here. In addition to that, we will also repair some equipment that I found at earlier trips to the scrapyards, like this Rema polishing machine, as well as this Metabo bench grinder that I briefly showed in the last episode. We will put quite a lot of work into that one actually. We will also repurpose some of the as of yet unused parts of this contraption here, as well as overhaul another bench grinder that I fixed in a video some years ago. With so much to do, let's not waste any time and get going. Let's take care of this Metabo brand bench grinder then. I actually started working on this machine in the last episode. A link to that can be found in the video description. However, for those who haven't seen it, let me briefly summarize what had happened so far. We found the bench grinder in a pretty rundown state, with lots of missing paint and rust on the outside. The bench grinder is powered by an induction motor, and someone must have connected a new power cord rather recently. However, no capacitor was installed, and the last owner probably tossed this machine onto the scrap because the motor didn't start because of that missing capacitor. This generation of Metabo bench grinders still has an enclosure made from cast iron segments. Later, bench grinder enclosures were made more and more from sheet metal or cast aluminum parts. This, for example, is a bench grinder from 2003, and I think this model represents what a typical low-cost machine looked like about 20 to 25 years ago. Even though of a much lighter build, it still had a little bit of substance left in comparison to the plastic enclosures you can find in some modern bench grinders now. But back to our old grinder. I took it apart step by step in order to have a look at the motor and to find out if there was any internal rust or damage. And this is where the last episode ended. Inspecting the parts, I didn't find any damage to the rotor or the stator windings. The bearings are still in good condition as well. But there was some rust and dirt, and I took care of that by wire wheeling some of the components while others were suspended in citric acid. And after cleaning and drying the parts, the grinder was reassembled and prepared for a new paint job. And since I don't have any paint that really resembles the old color, I decided to paint the machine in a light gray instead. At least for now. It would be rather easy to apply another layer with a Hammerite style paint later if needed. But more importantly, there are some pretty important parts missing. The two guards that normally cover the outward facing side of the grind wheels. In the past I have made rather improvised guards using sheet metal. But since I have spent the past few months learning about casting, we're now going to cast new guards from aluminium. The first step was to take measurements and then draw new guards in a CAD program in order to print patterns for the new guards. I don't normally show the 3D design process because so far I have used commercial software that I'm not affiliated with. I didn't want to do free advertising for them, and that's why I usually skipped over that part for the past 3 years or so. It's actually sad because it's an interesting process in itself and it actually belongs to what I'm doing here. But the situation has changed recently. I've been contacted by an American company that makes CAD software and they want to be my sponsor for a future video. And that's why you will actually see the design process in the next episode for the first time. YouTube is full of annoying sponsors that often have nothing to do with the channel or content. But if it's actually a good fit, I'm willing to try it. But more about that in the next episode. So I have used this setup for some months now and have since built better casting equipment. But that will be shown in a dedicated video about that. What you see is basically two wooden frames or open boxes. The lower one is called drag and the other one you place on top of it is referred to as the cope. You also need a sieve, which is typically called a riddle in sand casting. Before we can actually use the 3D printed pattern, at least for this particular cast, I first fill the drag completely with casting sand. In this case, most of the sand doesn't need to be put through the riddle and can be inserted with your bare hands as it is. Only the top layer that will actually touch the surface of the cast needs to be put through the riddle to achieve a fine grain structure or resolution, if you will. I then use a wooden rammer to compact the sand. Once that is done, an improvised strike bar, here actually just a piece of angled sheet metal, is used to level or strike off the surface. I had now arrived at a point where I wasn't perfectly sure how to proceed. In this first try, I made a little sand hill or mold and then placed the guard pattern on top of it. I tried to fill the hollow part of the pattern with sand completely, followed by brushing off all loose sand and then applying talcum powder to the surfaces, also using a paintbrush. The purpose of the talcum is to act as a separation layer between the pattern and the sand and also between the two halves of the mold. After placing the cope onto the drag, I used the riddle to fill it with finely grained casting sand. I do that as many times as is needed to create a stable layer of fine sand that is at least 2 centimeters thick and that won't break or slip off in the next step. After doing that, it is now possible again to just stuff raw casting sand on top of it until this upper part of the mold is also completely filled with sand. After filling it, I placed a piece of plywood on top that is supposed to help with the sand not falling out of this frame. Unfortunately, I made 2 mistakes here. One was to design the pattern without a draft angle. That is why it's so hard for me to wiggle it out of the cope. And the second mistake was probably to form a little hill of sand and then press the pattern on top of it. See, that hill was just a little too small and it simply didn't fill the inside of the pattern properly. But I thought that I could still salvage this first attempt to cast the guard and reworked the sand surface until I was somewhat satisfied with the results. After that, I cut a sprue and also 2 vents or risers into one half of the mold. In the meantime, I had heated up some aluminium in my electric furnace and was ready to pour aluminium into the mold. As you can tell from all the burn marks, I have used these wooden frames many times before, often with success, but also sometimes with failures. And after waiting for the metal to cool down, I found out that this one was a failure. One half of the mold must have collapsed or broken while placing it on the ground. But I already knew what I had done wrong and tried for a second time. This time I started by applying talcum powder to the pattern from all sides, making it easier to get it out of the mold even without a draft angle. And now I filled the hollow side of the pattern with sand and rammed it into the pattern. In the meantime, I have once again filled the entire drag with sand, and now I press the sand-filled pattern onto the surface so that the two bodies of sand kind of fuse with each other. And once again, talcum is applied. And now, in order to make sure that the cope and drag are actually properly aligned and don't move around during the process, I use screw clamps to fasten the two halves to each other. And again, the riddle is used to fill the upper part with fine sand before it is then pressed down. Just like last time, cope and drag are parted and the pattern pulled out. Some minor damage was unavoidable because of the missing draft angles in the pattern. I won't make that mistake again. But I successfully managed to rework the surfaces, and I think this time it'll work. And there you go. There is some excess material here, but it is paper thin and can be broken off by hand. After cleaning this up, it will be just fine. And since I need two guards, I repeated the process once again and again waited for the part to cool down. And here are the two raw casts. The risers still need to be cut, and I know that they look rather rough right now, but just wait a minute until I have cleaned them up. So I proceeded by first cutting off the sprue and risers with an angle grinder. Maybe they don't even need to be that massive in the first place, but when it comes to learning a new technique, a lot of it comes down to trial and error. And then in the next step I used an ordinary file to deburr the castings and get rid of any unwanted material that was still left. Until finally the casts were also wire brushed to get a smoother surface finish. And despite smaller imperfections, I'm quite satisfied with how these parts turned out. One thing that you can see here as well is that the rougher looking surfaces are actually just a copy of those rougher parts of the 3D printed pattern, where I needed to break off the support structures, that is. So I actually might have to put more work into creating smoother patterns if I want better results in metal. Since I made these casts, I actually invested a tremendous amount of time into improving my techniques and making better casting equipment in the first place. You will see more about that in the near future. In the meantime, I had checked one important thing, whether or not the castings actually fit onto the machine. And they did. They will be bolted down in just a minute. However, before that, new wires and a new motor capacitor were installed. For that, I had simply drilled two new holes into the steel sheet here that acts as the bottom cover of the machine, and an ordinary galvanized steel angle was bolted to it, and that is how the new capacitor is held in place. After drilling 3 new holes into each casting and cutting new threads into what is left of the old guards, the new outer guards were bolted in place. Moment of truth. So the new machine is running just fine, but I would need to build a stand or wall mount for the grinder so I can actually install it somewhere. So let's make use of this rusty piece of scrap next then. So where did this piece of steel originally come from? Well, maybe you remember that I built this magnetic drill here last year. And one of the components that I repurposed for that was this core drill assembly here that was mounted to it. At the time I had no use for it, but now the day has come. We don't need this bolt anymore, so I remove it with an impact driver. This wall mount is a little too big for the grinder though, and that's why I'll cut a piece off of it, marking the cut with a red line. The actual cut is made with an angle grinder before rounding off the corners in order to prevent potential injuries in the future. And I also did some wire wheeling, but there's actually not much loose paint left on this part as it was already suspended in acid months ago. I won't bother getting rid of the really tough remnants of paint. And this is where the grinder is going to be installed. So I marked the spots where the 4 mounting holes are supposed to be drilled. I thought at first that I could use the fine magnetic drill I repaired in the last episode, but it won't work because of the awkward position of some of the drill holes. The part is also just too big to be mounted on my drill press. This is a job for the milling machine then. And for those of you who haven't really seen it in action, this might be a good display of some of its versatility. First of all, I have to remove the vise. I use it for the majority of my work on this machine, but for this job it's only in the way. In order to remove it, I have to turn it by 90 degrees in order to reach the bolts that hold it down. This also allows me to clean parts of the machine that I couldn't reach before. And there is also currently an end mill installed that we also won't need right now, and that's why it's removed as well. Now, the nuts used for holding the vertical milling head in an upright position are loosened so that the head can be tilted out of the way and fastened again. Now, I removed this aluminium cover protecting the horizontal mill, but there's also still an old tool in there that was once repurposed to protect this part of the machine. In order to get it out, a bolt on the back end of this horizontal assembly needs to be turned loose. Only now can a new tool be installed. And what I need for this job is a drill chuck. In order to pull it inside, that same bolt is fastened again. But the vertical milling head would be in our way, and that is why I'm now retracting it. In order to do that, you first have to unclamp it. During operation, all movable parts usually have an additional clamping lever. Now, I'm positioning this weldment onto the table and bolt it down rather tightly. A drill bit is installed, and now we have to move the machine to the right position for the first hole. The holes have been pre-punched, by the way, before clamping the weldment down. In order to do this, the drilling machine can move back and forth in all 3 axes, and that can be done by a hand crank, as you can see here, or under its own power. I often do these things manually and use the feet mostly for actual machining, or in this case drilling. The feed rate needs to be adjusted, or otherwise the drill bit will be damaged rather quickly. With a machine like this, you also just have to listen and feel. As the old owner told me, this machine will let you know when she doesn't like something. And after setting up so many things manually, it's then actually a joy to see the machine drill the holes by itself. No matter what kind of work you do in a workshop, the actual operation is often just a tiny fraction of the work process. Preparation of workpieces and machines, including keeping the shop orderly and clean, is often more than half the job. But be that as it may, with the holes drilled, the grinder could now be bolted to this wall mount. But before it will actually be used, I still have to find a good spot for the machine. Well, while I'm thinking about it, in the meantime, it received a new coat of paint. And I think it'll go together quite nicely with the old Metabo grinder. Before we will move on to completely different objects, let us have a brief look at this polishing machine, as well as this green bench grinder here, that has one very important lesson in store for us. So this old polishing machine, that also could have been a grinder in another life, was made by the German company Rema. They are known for making extremely durable grinders, like this one over here. Rema also made similar machines for the German armed forces. Our machine here is much smaller, of course, but you can tell that it has the same exact shape as that bigger one. And this is yet another stationary machine that I found without a capacitor installed. And the biggest problem is that it has a hole in that cast aluminum enclosure. However, almost certainly that hole was only punched into it at the scrapyard, because a heavy piece of scrap of some sort must have fallen down onto it. Compared to the last machine, I got downright lazy here and simply fixed that hole by closing it with a polymer adhesive. In order to get the motor to start and run properly, it also needs a capacitor. And I once again used off-the-shelf galvanized steel angles for that. To arrive at the specified capacitance, I decided to connect two 5 microfarad capacitors in parallel. And because I didn't want to buy any new replacement parts for this old timer, I'm reusing two old capacitors here that were salvaged from two Miele dishwashers. These capacitors are 30 years old, by the way, as the date codes show. However, I'm going to call this an experiment to see how long really good capacitors can actually last. And since the topic of induction motors and capacitors has been following us since the last episode, there is also an important lesson that I want to talk about as a response to some comments under the last video, and the next object has to do with that directly. The comments that I'm referring to had mentioned that they had seen machines with missing or broken capacitors that they would simply start by hand, and that probably worked just fine. So what's so important about the capacitors then? Are they even needed for running the motor or just for starting them up? The answer is a bit more complicated, and here it is. In episode 10 of the Scrapyard Repair-A-Thon series, published on February 29th, 2020, I presented this green bench grinder here. That bench grinder had one typical problem. Inside the bench grinder we found an induction motor with a centrifugal switch that is supposed to disconnect the starting capacitor once the motor has spun up. The motor would then run without a capacitor after that. But the centrifugal switch was broken, so I built an electric circuit instead to do the job of the centrifugal switch. So far so good, and that grinder has been doing its job for 5 more years with that circuit in place. However, as of late the motor feels very unstable during startup, and that's why I have revisited this repair job, only to find out that the old 80 microfarad capacitor has finally given up. There is literally a charred hole burned through the casing of the capacitor. I took this as an opportunity to change a few things here. I replaced the old screw clamps and wires with new wires and heat shrink, and also installed a somewhat smaller capacitor. I also cleaned the machine and installed wire brushes in place of grinding wheels, as I really have enough grinders in the shop right now. So that machine is back in action. But what was the point that I was trying to make here earlier? So when we had taken apart that Metabo grinder entirely, we could clearly see that there is no centrifugal switch installed there at all. The same is true for the Rema polishing machine. And frankly, the same is true for just about any German-made induction motor that I have ever seen. And this is quite different in America and many other countries around the world. Many of your bench grinders and some other machines will have those centrifugal switches. So why is that? The reason is that there are several different kinds of single-phase induction motors out there. And I have actually attached a PDF under this video which explains the different types in detail. But to make it short, some induction motors have only a start capacitor with very high capacitance, like here 80 microfarad. Others have a permanently connected run capacitor with smaller capacitance, typically 10 or 15 microfarads or thereabouts, while others have both, meaning they have a permanently connected run capacitor as well as a start capacitor with a switch. None of these solutions are perfect, as running induction motors on a single phase is always just a workaround. The proper way to run an induction motor is with polyphase alternating current, like 3-phase power. And that is the solution that you will find in really heavy and high quality professional equipment. However, when it comes to single-phase induction motors, the typical solution, here in Germany at least, is to have a permanently connected capacitor. This approach has lower starting torque, which doesn't really matter in grinders that much, but the motor also runs smoother, and there is no centrifugal switch that can create sparks or break, as it happened with that green machine. However, this also means that the machines I find here in this part of the world typically really need a capacitor to run with sufficient torque and power, while in the country you happen to live in, it might actually be enough to start the motor by hand and run the machine without a capacitor, as dangerous as that might be otherwise. But if you want to learn more about that, then maybe check out that PDF that I linked in the video description. Let's have a look at this unusual looking contraption then. It obviously is some kind of optical device, and alongside the main unit that obviously has a screen of some sort, I also found two spots or light sources that had been separated from the main enclosure. And just like the World War II era hydraulic pump that I showed in the last video, I mostly brought this item to talk about its historic value. I don't have the time right now to decide if I really want to restore it, but at least I wanted to find out what this is and talk about it a little bit. Upon opening the bottom of the enclosure, we can peek inside, and what we find is a small mains transformer, probably for the light sources, as well as a mirror and a screen. The entire enclosure is painted black from the inside. In the front we find a lens, but I'm sure that there is something missing here. So what is this strange apparatus and what is it that is missing? Well, upon doing a little bit of research, I found out that a man by the name of Robert Plagwitz, son of a photographer, moved to Berlin when he was just a little boy, together with his family obviously. That would have been in the early 20th century. A true self-made man, he became an optical instrument maker and inventor of various optical precision devices in the 1920s. As I can read in this old newspaper article, his machines were in worldwide use to focus the bulbs in automotive lights, for example. And the contraption we have found looks a lot like this picture here from an old advertisement. A profile projector. Other names for this might be optical comparator or shadow graph. What is missing from our Scrapyard device is a height adjustable stage, as you might know them from microscopes. The light sources contain these old light bulbs here that are still in working order. As these pictures show, these devices could be used to inspect the contours of small objects in quality control. Right now, I still have to decide if I can spend the time to bring this contraption back to life. Unfortunately, the metal enclosure has been severely dented at the scrapyard. But whatever I will decide to do with these parts, at least I wanted to share this historic curiosity. And going from one odd object to another, let's have a look at this pile of equipment then. As you can see, I have brought with me 4 rather similar looking devices. There are a few important differences between them though. So what are these things? Let's start with this one. The German company Alba manufactures these devices as part of their Scala Mobil series of products. And it is an aid that is meant to connect to a wheelchair, as can be seen in this promotional video here. A second person can then help to lift a person on a wheelchair, weighing up to 140 kilograms, up and down stairs in buildings that don't have an elevator. You would require just the right amount of motor action and braking to make this safe. These things must be built really sturdily, and you can imagine how much testing would have to go into products like this to be deemed safe. For that reason alone, every one of these devices would have cost thousands of euros when they were new. I'm not sure it will be morally justifiable to just resell these units though, so I think there's no money in it. But maybe I can repurpose them for my own means. But for that, we'll first have to get them running again. So I'm starting with this unit here, because it's the only one that actually came with a battery. That battery, however, is dead, and a new replacement costs 300 euros or even more. And see, while some repairs are super challenging, like learning to cast your own replacement parts, or even developing a circuit to bring something back into service, other repairs are actually quite trivial, like an induction motor missing a capacitor or a dead battery. Upon opening the enclosure of the battery pack, however, we find out that these are two ordinary 12-volt lead-acid batteries that can be purchased for around 20 euros each. The old batteries have almost no voltage left and cannot be saved. Ideally, the voltage across the two terminals of a 12-volt lead-acid battery should not fall under 10.5 volts or so. If you are at 0.5, I'm afraid you'll just have to buy new ones, and that is what I did. So I installed the new batteries, but you also need a charger, or those batteries will be dead pretty soon as well. And of course, the original charger is also super expensive. So I bought a much cheaper standard lead-acid charger for 24 volts. The only thing I needed was to change the connector that came with it to a different type that would actually fit the Scala Mobile. And of course, I don't have any actual experience with using these devices as intended, but I'm sure that this one works exactly as it should. Let's have a look at the second unit then. It is a similar design, but a somewhat more recent model, around 2010 or 2011. Unfortunately, one of those smaller wheels is missing. I contacted the manufacturer and asked if there might be replacements for that. After all, it's just a little aluminium wheel with a bit of rubber. But they told me that there is pretty much no chance that anyone still has parts for a model that old. You see, most people have quite a different idea of what is new or old, compared to me anyway. So this time no battery came with the device, but by mere chance I was able to acquire a dead battery that seemingly fits with all kinds of models in the series. Inside we once again found ordinary off-the-shelf lead-acid batteries that I replaced myself. And there you go. The workshop doesn't have any staircases, but maybe I can modify these devices to use them as powered hand trucks and test them once I have found a safe spot, for lifting hundreds of kilograms up some publicly accessible stairs with a piece of machinery I found on a pile of scrap without causing an emergency. I know, you've heard it 1,000 times. That leaves us with the two remaining devices. They are much simpler versions that weren't built for stair climbing, but simply for assisting to push people in wheelchairs, maybe up a ramp or maybe just on level terrain, not sure. But they are much less valuable and I don't really have a use for them as they are. However, they do have a very powerful DC gear motor inside and I already have a use for that. That is, however, a story I will tell you in another episode. So that is all I had for you today, a wild ride through very different fields, but I really hope that you have learned something along the way, or at least have found some inspiration here. If you liked this video and want to see more Repair-A-Thons in the future, please give the video a like. That would be of great help. And in case you want to support future video production, please consider making a donation. A link for that can be found in the video description and in the comments. Or consider becoming a supporter on Patreon under patreon.com/tpai. See you soon.